7.2. Verify. Just keep it short, trig identities. So notice here on number 3, you give an equation and you have to verify that it's true. So in this example, they're basically kind of hinting at what to do. On the actual exam and later in the homework, they're not going to tell you anything. They're just going to tell you, how do you get to, how is this equal to 1? And you got to show your work. So remember that page I gave you with all those identities, give you a prep time? Those all have to be used during those steps. So you don't have to memorize them, just have them when you're doing this homework or the test, make sure you have all of them with you. Okay, so let's do number 3, example 1. And we're not solving for anything. It's just going to keep, the whole time is going to be just verifying. 0. There's only one I, right? So the general idea, switch over in just a second. The general idea is to show how this is 1. About 99% of the time, you assume that's true. I don't think they're going to give you a curveball where it's a lie. You got to prove it's wrong. It's going to be true. And you need to figure out how do I get from one side of the equation to the other side. The general rule is that you choose the most complicated side, because the simple side is hard to deal with. Because if it's too simple, you're like, well, how the heck do I get to, like, for example, if I start at 1, how do I turn a 1 into this, right? That's hard. But if I start with this side, maybe that can cancel out and give me a 1. So I'm going to choose this. So you start there. So the first thing you do is pick a property. So if you look at that, all those identities I gave you, there was one that was called, I think, a quotient property, right? Do you remember what tangent was equal to? Part of the quotient properties. I think it was in that green sheet that I gave you. You guys still have those? I have one more if someone needs it. That's pretty gross, grossly stained. You want this? Someone left the eraser and the marker. Look at the I think you're calling ratio. Remember at the start. I give you a ton of them on the notes. I would prefer to use ones in the notes, just in case. I don't know if they're all on here, but whatever. It doesn't matter. But look what the ratio says. Ratio says that tangent is equal to this, right? And cotangent is equal to this. And I'm going to write down on the side what property I use by ratio or quotient. Different books call it different things. Same thing. So now you should see that these are going to cancel out. So sine theta times cosine theta over cosine theta times sine theta. So you see how this cancels out, right? So when something cancels, you're left with a 1, not a 0. don't forget. Everything canceled out. So now I have verified that this is indeed equal to 1. Did you see how the process works? Like what you're gonna have to do. Now let's look back at the homework. In the homework, they're kind of breaking it down for you. They're giving you the hint. I don't want you to rely on this too much, but it's fine to fill in the blanks. But you should be able to look at this and say, okay, I should change that into a ratio, to a quotient. See what happens. You basically just want to try something. You look at your properties and say, all right, what can I use here? And after a while, you start to see a pattern. Like if you see tangent, you should think sine over cosine. If you see a sine squared, you should think of the Pythagorean identities. It's one of the other stars on there. Stuff like that. Like this guy. Let's start on the left side, I guess. Any questions on example 1 though? I'll switch back in a second. Writing down the problem. 1 plus sine times 1 minus sine equals cosine. So I don't care what they're doing. What we need to do is verify. But you guys cool on number 1? So multiplying, this is a conjugate pair. Do you see how this is a plus b times a minus b? These always multiply into the difference of squares. Okay. You remember that this is equal to a squared minus b squared, right? Is this familiar? You probably first saw this in middle school, way back when, but it keeps coming up over and over again. So here you have, see how they're the same thing, they just differ by a sign, right? Whenever you see that, you should know that's going to multiply like this. If you don't see that, you could FOIL the whole thing out, and then you're going to end up with just these two terms. Everything else will cancel. So you can use this formula because 1 squared is 1. B is the sine. Sine squared is right there. So do you guys follow me? I use the formula. If not, let me know. You could have started there. We'll do it both ways in a second. So because right now we're going to use Pythagorean anyway, right? So because you see this is cosine, correct? Under the Pythagorean formulas, that's equal to cosine. Pythagorean. And that's what we wanted to show, that this is equal to that. Now, if I would have chosen to start here instead, I would have said, yeah, that's equal to 1 minus sine squared by Pythagorean. then I would have said, well, this factors into a difference of squares, right? So I would end up on the other side anyway. So in this case, either side would have worked. Technically, you can start in any side. Just sometimes, usually one side's easier, but I think in this case, they're about the same. So this is a alternate method here. Any questions on 2? Did all right? It's like weird Sudoku, remember? Just playing a game. That's all we're doing. And the rules are on that green sheet. So in the homework, they would first have you multiply it out and show that this is actually a sine squared here. And then that would eventually become cosine. So they did less work on here. But eventually you're gonna have to do this anyway, so you might as well do it this way. Okay. Let's see if it changes. No, they don't. Let's see, add some more. That's fine. I was using the wrong notes. My bad. It's like, why can't I find anything? Here it is. Okay. So we use the same one anyway. Let's do that cosine one next, I guess. You guys cool in the first 2, right? You guys cool if I turn the page? All right. So I don't have COVID, but I do have a cold. So. Cosine squared beta minus 3 sine squared beta equal to 6 cosine squared beta minus 3. What side do you think we should start on? Yeah, I think the left might be better. So 3 cosine squared minus 3 sine squared. So what do you guys think we should try? You just got to try something. What does your intuition tell you? What property should we use? Yeah. We should use a Pythagorean. Since we have squares, that should be the first thing that comes to your mind. Like, all right, probably one of the Pythagoreans. Now, look on the right side. We have cosine, right? There's no sines. So that's another hint that we should probably change this one to a cosine and see what happens. So let's see what happens. I'll leave this guy alone. So that becomes 1 minus cosine squared. Right? That minus 3 is right there. So I'm going to have to distribute the minus 3. I mean, minus 3 times 1, minus 3 times that guy. So that'll become a plus 3. Right? Now,
what identity was that you used to get it from?
here to here. That was the Pythagorean, you said.
Like because sine squared is beta equals 1 minus cosine squared, that's right?
Yeah. We use this guy.
Oh, I should have been more specific. 'Cause that's not. I was looking at a different identity from that same group.
Oh,
Does it
okay.
make it different? By the way, because I'm curious, and you mentioned it before, there's many ways to get some of these same things, right? So like, would sine squared plus cosine squared equals 1 be another way to get to the same thing?
If we can use it, you should always try to use that, but we have a minus. There's no way we can force it to be both
I
plus.
see. Okay.
But you can create the situations on purpose. Sometimes that helps. But
I missed that detail.
But as far as yeah, what I want you to do is just try anything and see what path that takes you on. Sometimes it's a longer path than another thing you could have done, but you'll eventually get there. You just might take a really roundabout, way. But as long as you're using the right properties, your algebra is good. Eventually, you'll get there anyway.
Just to verify, though, in that instance, that is incorrect, and I would not have gotten the correct way.
Yeah, we
because
can't.
There's no way to change the sign. I missed that. Like, I didn't
Yeah, if this was a plus, this would turn into a 1,
Okay.
but it'd be times the 3. Because you factor the 3 out, and then the inside would be a 1. But yeah, it would not have come out right. You're right. Okay, so you guys still with me up to here? It's okay. So 3 cosine plus 3 cosine, that's going to be 6, right? And that's what we wanted to show. Cool. So that's all we're trying to do is get to the other side. So that proves that they are equal using our properties and identities. Excuse me. Interesting. All right, 2 over 10x plus 2 over cot. Is this equal to 2tan plus 2 cotan? It's not,
Just change it to X. Or
yeah, 2 tan x plus 2 cotan x. Let's start with the left side because it looks uglier. Now, there's a couple of ways to do this. You can add the fractions and see what happens. But I'm starting to see a shortcut now. Do you agree that this is the same? Yeah, right? Same thing. Now, when you write it this way, it's more obvious. Do you see what the reciprocal property can do for us? Right. What is 1 over tangent? Yeah, this is cotan right there, isn't it? What is this guy? 1 over cotan. Right, that's the reciprocal. Yeah. And that's what we wanted to show anyway, isn't it? So that would be the shortest path to get there. Not the only way. But in my opinion, this is the shortest way. So reciprocal identity is what we used. This last step was unnecessary, but whatever. There it is.
go from 1 over cotangent. But we, because it kind on camera with cotangent, but if you do one, like in the reciprocal identities, like you kind of just do like a new basic question. The numerator divided by 1 equals 2 equals same thing, kind of.
Let me see, I don't have the sheet.
Like cotangent on your
Yeah, it works both.
yeah, so I can put one.
Yeah.
So you just regular.
Yeah, you can flip both sides over. And they're reciprocal to each other. The tangent is equal to 1 over cotan. Cotan is equal to 1 over tan. It's either way. Okay. Any other questions on 4?
Does that apply to all of those properties in your, so like would the reciprocal of like secant then be the same, the same idea be there, so be the 1 over
Yeah.
secant as well?
Yeah, because cosine is equal to 1 over secant, right? So secant is equal to 1 over cosine. Sine would be equal to 1 over cosecant. Cosecant 1 over sine. So that, yeah, that's technically true. I believe it might be in the notes we did last time. Anyway, do you get the idea on these problems? So the approaches you're going to see is change tangent to sine over cosine. If you see fractions, get a common denominator and add them. That's usually a good site to start on. Sometimes doing a multiplying by a conjugate helps, but I don't think it's very uncommon. Let's do one more and then we'll move on. Yes,
What's a conjugate in this context?
it's the difference of squares products. So a plus b times a minus b. Those are conjugates.
Conjugate in this sucrose.
Math conjugate. Very good. These are conjugates. Both supposed to be b's. Okay, verify. 1 plus sine theta over cosine theta plus cosine theta over 1 plus sine theta equals 2 secant. What side would you start on? Yeah, I think left is better. So when you see this left side, you see two fractions being added together. So add them together. What is the LCD here? Yeah, for both fractions, LCD is going to be cosine and 1 plus sine, right? So LCD here is this. So introduce this to both fractions, whatever they're missing. So this one needs a 1 plus sine. And this one needs a cosine. Very good. All right, so multiply by 1 plus sine over 1 plus sine. And then multiply this guy by cosine over cosine. So once we do that, we will have the LCD on both. So we're going to have 1 plus sine times 1 plus sine up here over cosine 1 plus sine plus cosine squared over cosine times 1 plus sine. So they have the same denominator now, so just add the numerators. So add these two. So we're gonna have 1 plus sine squared plus cosine squared over that denominator. You guys follow me on these fraction steps. If your fraction game is weak, let me know. If this is messing with your head, not a big deal. You see what we're doing, right? So once I introduced the common denominator, cosine became cosine squared, cosine is that bottom garbage. I left that alone. I didn't multiply it out. This introduced 1 plus sine here. So multiply that out, you get a square. That's a square. So now once they're the same, you can put them over the same fraction. That was the whole point. So now that we're here, multiply this out, and you're going to get 1 plus 2 sine plus sine squared plus cosine squared. So this right here multiplies out to these three terms. I didn't show the work there, but do you see that? Now notice there's a sine squared plus cosine squared, right? Let's go ahead and apply it. Yeah. That becomes a 1. So that'll give us a 2 plus 2 sine, right? Now factor that 2 out, and you should see something cancel. See where we're going with this, right? Final step here. This is 2 times 1 over cosine, right? What is 1 over cosine? Yeah, secant. This is what we wanted to show. Any questions about any of those steps? See how they can sometimes get a little involved, but all you're really doing is adding fractions. So just because it looks weird doesn't mean you haven't done this before. Right? It's like if I'm adding a half plus 2/3, it's the same garbage. It's just that they're not numbers, they're just strange little functions. And when you multiply them out, they sometimes become things on your formula sheet. So all these steps up here, right from here to here, I'm just adding fractions. Nothing fancy. And then here I apply some pre-cal stuff, algebra, and then again pre-cal, finish. Any questions on 5? That's pretty much it. You're going to see a bunch of that type of stuff over and over again. we'll stop examples there for now. I want you to try a few of them before you leave, though. I think they're exactly the same, right, in your homework? Or do the numbers change? I don't know if your numbers change. Try number 6. Can you finish that? This topic is hard to, it's hard to show you how to do it. You have to try it. Just write the question down. Don't worry about all that other stuff. So you don't get tempted. It's right there. 6.